Most of the People's Liberation Army's surface-to-air missile systems are designated members of the Hongqi, or the Red Banner family, reflecting their revolutionary roots. These red banners have come a long way, from just a few batteries of imported Soviet SA-2s to an expansive family of systems, with elements covering from just above the treetops to engaging targets beyond the atmosphere. So, let us talk about these red banners flying over the People's Republic with an overview of the PLA's surface-to-air missile family. Here is a simple sequential view of all PLA SAMs with the HQ or Red Banner designation. The HQ-1 is the PRC's first domestically produced SAM system, a reverse-engineered version of the famous Soviet S-75 Divina or NATO designation SA-2 guideline. The HQ-2 is an improved version of the HQ-1. Most notably, the system had better resistance against electronic countermeasures employed by the Republic of China's fleet of spy planes, such as the U-2. The HQ-3 is a further enlarged version of the HQ-2, with the aim of taking down the renowned SR-71 Blackbird. It made it to limited serial production, but failed to achieve its goal of threatening the SR-71. The HQ-4 signaled a radical departure from the previous systems, as it was no longer based on the S-75. Once again aiming to engage the SR-71, the missile adopted solid fuel propulsion to reduce reaction time and increase readiness. However, the HQ-4 still could not effectively engage the SR-71, and the program was terminated before entering production. The HQ-5 was the PRC's first attempt to build something akin to the Patriot system. Given the sorry state of PRC's R&D capabilities in the wake of the Cultural Revolution, the challenge was immense, and the program was cut short. The HQ-61, HQ-64, and HQ-7 were neither Soviet nor Chinese designs, but rather Western systems procured as spoils of war, as well as through legitimate and illegitimate business dealings. The HQ-81, later named Fanji, or Counterattack 1, is the PRC's first attempt at ballistic missile defense. It was aimed to be a tech demonstrator for new technologies required to develop a successful terminal missile defense system. I call these missiles the PLA's early SAMs, as the source missiles and technologies were all obtained during the Cold War. To summarize, the PRC's technological isolation after the Sino-Soviet split, in concert with the destruction of its scientific institutions in the Cultural Revolution, severely hindered its ability to develop SAMs that could keep pace with the evolution of threats. Despite having some level of access to more sophisticated Western technologies, the factors above made reverse engineering extremely difficult. In some cases, the domestically produced version would become obsolete before making it to production. For almost the entirety of the Cold War, the Soviet S-75 and its derivatives, the HQ-1 and HQ-2, were the only operational SAMs that the PRC could rely on to protect its airspace. As the Iron Curtain was lifting in Europe, Sino-Soviet relations defrosted and the Soviet Union dissolved shortly after. The PRC gained renewed and expanded access to top-of-the-line Soviet and Russian defense technologies. Together with Western technologies acquired during the short-lived honeymoon period and the rapid reinstitution of domestic R&D capabilities, the PRC successfully developed a large selection of modern surface-to-air missiles. Development on the HQ-9 started in the 1980s, building on the experience of the HQ-5 project and with significant influence from the imported S-300 systems. Its development was long and arduous, taking over 20 years. Only until 2005 was the HQ-9 approved for mass production, as the PRC's first successful attempt at creating a third-generation long-range SAM. The HQ-10 is the Chinese equivalent of the US CRAM Point Defense System, equipped on almost all modern PLA surface combatants since the early 2010s. The HQ-11 is a terminal SAM specifically designed to intercept modern precision-guided munitions. It was only officially revealed in 2022. The HQ-12 is interestingly a member of the Soviet S-75 missile family. The bloodline of the Soviet S-75 from 1957 is still present and serving the PRC today. The HQ-16 is the result of the PRC's effort to reverse engineer the Russian Shtil missile obtained through the purchase of Sovremeny-class destroyers. The HQ-16 family would later double and quadruple the range of the Shtil missile. The HQ-17 is a reverse-engineered version of the Russian Tor M1. Originally, the PLA purchased a few batteries and then requested from the Russians a transfer of technology agreement to establish domestic production. But when the Russians refused, they decided to go ahead anyway with reverse engineering. The HQ-19 would be a notable embodiment of PRC's advancement in SAM technology. First publicly revealed in early 2020, but said to be in limited operational roles around 2017, it is capable of both endo- and exo-atmospheric missile defense with a kinetic kill vehicle. The HQ-22 entered PLA service around 2016, at first to replace HQ-2, and later HQ-12 systems as well. It offers good long-range air defense capabilities against fixed-wing aircraft and some ability to defend against cruise missiles at a lower price point compared to other PLA long-range SAM systems. The HQ-26 is the PRC's analog to the US Navy's SM-3 missile for mid-course ballistic missile defense. It is yet unknown if the missile has entered into service, but we have seen photos of it in testing as early as 2016. These are the PLA's modern Red Banner SAM system. Here, I wish to further illustrate the diverse sources of the early PLA SAMs. The HQ-1, HQ-2, and HQ-3 all trace back to the Soviet S-75, sold to the PRC under Khrushchev as the Sino-Soviet bond was still strong with full technological transfer and technical support to establish domestic production. But 2 years after the delivery of the first SAM system, the Sino-Soviet split abruptly ended all Soviet contributions to the PRC's SAM program. So it took until 1964, a total of 6 years, for the PRC to establish manufacturing of the HQ-1. For the HQ-4, HQ-5, and HQ-81, there's very little evidence I could find pointing to foreign technology access. The HQ-61 was built on top of technologies acquired from several AIM-7 or E missiles that the PRC obtained through aerial engagement near the Chinese island of Hainan during the early days of the Vietnam War. The HQ-64 and HQ-7 have European ancestry. In particular, the HQ-64 was built on the Aspide Mark 1A, air-to-air missiles that the PRC imported from Italy in the late 1980s. The HQ-7 story is a bit more complex. The PLA likely had access to a few French Crotale surface-to-air missile systems for a very limited period of time when they were evaluating the system for possible purchase. The PLA was very impressed by the system but could not afford it. Instead, at a later time, it secured some second-hand systems for reverse engineering. Let us dive deeper into the details of those early PLA SAMs. Between September and October 1957, the PRC's then Vice Premier in charge of defense production, Ni Rongzhen, visited the Soviet Union and signed the Sino-Soviet New Defense Technology Accord. In this document, the Soviet Union agreed to export an extensive list of military equipment and technologies to the PRC, mainly focused on missile and nuclear technologies. This would include the S-75 SAM, which just entered Soviet service the very same year. With the missiles came the PLA's first-ever SAM unit. In October 1958, the 1st SAM Battalion of the PLA Air Force was established under the code name Unit 543. A month later, in November 1958, the equipment for the battalion, an S-75 battery, was delivered to the PRC via railway. It set the tone for future PLA Air Force SAM unit organization, that a SAM battery, the most basic firing unit of a system, is designated as a battalion. A total of 5 battalions or batteries were directly delivered to the PRC, with others planned to be produced domestically. All the 5 battalions at that time were deployed around Beijing. The existence of these SAM units would bring an ominous fate to the high-altitude reconnaissance aircraft and personnel of the Republic of China Air Force. Previously, they had enjoyed a period of invulnerability as their newly acquired RB-57D high-altitude reconnaissance aircraft could comfortably fly above the reach of the PLA Air Force interceptors. On October 7, 1959, 2 days after the 5-day celebration for the 10th anniversary of the People's Republic of China, a RB-57D was dispatched to conduct a photo reconnaissance mission directly above Beijing. Unbeknownst to the pilot and mission command in Taiwan, the PRC's S-75 missiles laid in waiting. The shootdown of the RB-57D was the first ever combat kill of any aircraft by a surface-to-air missile. Realizing that the RB-57D was no longer safe, the U.S. equipped the ROC Air Force with its most advanced spy aircraft, the Lockheed U-2. With it, an elite reconnaissance unit was formed, the famous Black Cat Squadron, the 35th Squadron of the ROCAF. Now well aware of the deployment of S-75 batteries around Beijing, as well as the scarcity of available SAM units, the U-2s would avoid flying over the city. By doing so, they would penetrate PRC airspace with near impunity, as the PLA could not afford to defend anywhere else with its SAM units. In 1962, the PLA devised a scheme to ambush the U-2. By purposefully repositioning a few of its tactical bomber units, it attracted ROCAF's attention, as SAM units were clandestinely positioned into the possible flight path. On September 9, 1962, the PLA Air Force successfully shot down a U-2 with the S-75 SAM. In the coming 5 years, 4 additional U-2s were lost to the S-75, HQ-1, and HQ-2 SAM family. 5 out of all the 7 U-2s that were lost in combat were from these SAMs in the PRC. If we include the more modern HQ-12 SAM into the S-75 missile family, as it should, it is the longest-serving SAM family from 1958 until now, 66 years and counting. Since most of the HQ-2 were produced during the Cultural Revolution, their quality, together with the PLA's ability to maintain them, were significantly degraded, yet it still managed to score a few kills during the protracted Sino-Vietnam War. In 1984, it damaged beyond repair a Vietnam People's Air Force MiG-21R conducting reconnaissance inside PRC airspace with another kill in 1987. This was the last time that PRC's SAM units scored a kill in actual combat. Although proven, the HQ-2 was plainly too outdated even for the PLA in the early 1970s. Before the HQ-2B, the PLA had already received an improved HQ-2 variant, the HQ-2A. The major improvement on the A variant is the better liquid fuel storage capability. The liquid fuel can be stored in the missile itself for an extended time. Compared to earlier HQ-2, which required fueling before launch, the reaction time of the system was reduced by a great margin. The HQ-2B is the PRC's attempt to bring the aging HQ-2 missile into the digital age, utilizing integrated circuits in both the missile and the fire control systems. Other improvements include an added electro-optical tracking device to better engage low-flying targets with better resistance to jamming, improved fuse and engines for engaging supersonic targets. The HQ-2B served the PRC until the year 2020. The HQ-12 is the last and most modern member of the long bloodline of the S-75. We can see it retains some basic features of the S-75, but with a significantly reduced size. The extremely long lead time between project inception and induction into the PLA was mainly due to the PLA being dissatisfied with the early versions and their decision to wait for the later iterations. Even amidst the chaos of the Cultural Revolution, the PRC did not stop the effort to advance its SAM technologies because it was at odds with both the Eastern and Western blocs. And that left us with a few interesting but obscure dead-end projects. The overhead photo reconnaissance of U-2 subsided due to the overwhelming threat of the S-75 SAM family. The last U-2 mission into PRC airspace took place on March 16, 1968. The PRC was made aware of the existence of the SR-71 and the immense challenge it posed to existing air defense systems. So in 1965, they began to develop the HQ-3, an enlarged version of the HQ-2, to try intercepting the Blackbird. The HQ-3 was able to reach a maximum speed of Mach 3.5 and an altitude of 30,000 meters. But by the time it entered limited serial production, Sino-US rapprochement and the development of satellite imagery made SR-71 flights over mainland China unnecessary, and the project was cancelled. The HQ-4 project was a lot more ambitious, incorporating advanced technology in multiple facets of the system. In terms of guidance, it abandoned the old all-the-way radio command guidance. It adopted a composite guidance scheme with radio command for mid-course and semi-active radar homing for the terminal phase. In terms of propulsion, it adopted a two-stage design with solid fuel rocket engines for both stages and aimed to achieve an aggressive maximum speed of Mach 6 to 7. The airframe design was also significantly different from the S-75, with 4 long delta wings closely followed by 4 control fins. This is similar to the AIM-54 Phoenix, which also had high speed and high altitude requirements. However, it would be impossible for the Chinese to access Phoenix samples then. The HQ-5 was also overly ambitious for its time. It was aiming at a similar performance with the Patriot, even when the Patriot itself just finished development. As an example, it called for an engagement radar with 1,000 phase shifter modules, though at that time, the maximum number of modules that the PRC could assemble on a reasonably sized antenna was 60. During the 1980s, the PRC shifted its focus from national defense to more generalized economic development. The HQ-5 project was terminated in a series of departmental restructurings. The story of how the PRC might have obtained the AIM-7 missiles begins in the Gulf of Tonkin in April 1965, where just months earlier, another fateful event had propelled the US into the Vietnam War. Up until April of that year, the carrier USS Ranger was operating under Task Force 77 in the Gulf of Tonkin, conducting airstrikes against North Vietnam. On April the 9th, a formation of 4 F-4B Phantoms was dispatched to conduct a routine combat air patrol mission. But somehow, they went too far and drifted towards the Chinese island of Hainan. 4 J-6 of the PLA Navy Air Force were scrambled from Lingshui Air Base to intercept the incoming U.S. aircraft, and the situation quickly devolved into an aerial engagement. Accounts conflict on the details of the engagement, but it is certain that several AIM-9 and AIM-7 missiles were fired, and a U.S. Navy F-4B with build number 151403 was lost in Chinese water. The PLA wasted no time and retrieved the wreckage together with the AIM-7 missiles carried by that plane. It is thus no coincidence that in 1965, the PRC kick-started a new SAM program based on the retrieved samples. Then, named HQ-41, the project was formally approved by the Central Military Commission in 1966 and renamed HQ-61 in the next year. Owing to the Cultural Revolution, the project encountered tremendous difficulties. The HQ-61 ultimately took 21 years to pass all trials in 1986, with production approved after another 2 years. The resulting SAM can be seen as an enlarged derivative of the AIM-7 or RIM-7, the Sparrow's ground-launched variant. The missile is about 10% longer, with a 10% larger wingspan, and is almost 34% heavier compared to a Sparrow. It also has a slightly different wing configuration. The Sparrow has wings and fins all set with an X-shaped configuration, while for the HQ-61, the wings are installed in cruciform, while the control fins at the back are installed with an X shape. Unfortunately, the performance of the HQ-61 was underwhelming. Even with the enlarged size and weight, it only achieved half the range of a RIM-7. The HQ-64 can also be seen as an offspring of the Sparrow missile. However, the linkage is not as direct as the HQ-61. The HQ-64 is built on top of the designs and technologies acquired from the arms deal made between the PRC and Italy regarding the Aspide Mark 1A beyond visual range air-to-air missiles. Interestingly enough, this deal was part of the larger Peace Pearl program, in which the United States is responsible for upgrading PRC's J-82 fighters with advanced avionics such as the ANAPG-66 radar. We have to take a moment to note the sharp contrast between the origins of both the HQ-61 and HQ-64. The former was born out of intense hostility between the PRC and the US, while the latter was rooted from deep military cooperation between the two countries just 20 years later. The HQ-64 has a closer resemblance to the later Aspide 2000 SAM than the original Aspide Mark 1A air-to-air missile. It is unknown if the PRC had further access to those or if it was just a convergence of design due to the need to convert an air-to-air missile to a surface-to-air missile. The HQ-64 missile is an integral part of the HQ-6A or D short-range air defense system. One HQ-6A battery is made up of one target acquisition radar, two large vehicles carrying both the missile engagement radar and a 7-barrel 30mm close-in weapon system, and 6 launchers with 4 HQ-64 missiles each. As mentioned previously, the PLA favorably evaluated the French Crotale surface-to-air missiles but could not purchase them due to budget constraints. They eventually laid hands on a few sets of second-hand systems that were in service with the Pakistan Air Force to kick off their reverse engineering effort. This was significant for the PRC's SAM development, as it was the first time they gained access to top-of-the-line Western systems that were designed to target low-flying targets. However, this is just a drop in the bucket in terms of the overall defense cooperation between China and Pakistan, which I intend to cover at a later time. Once the PRC successfully developed its HQ-7 SAM system based on the French Crotale and made improvements, Pakistan happily bought the export version FM90 to equip its army. The HQ-7 was approved for production in 1988. It achieved another milestone for being the first tri-service surface-to-air missile that was used in the PLA Ground Force, Air Force, and Navy. In this video, I mainly focused on the PLA's early SAMs with missiles and technologies acquired during the Cold War. In a future video, I will move on to discuss more about the PLA's modern SAMs. Please stay tuned.